Hello friends, grab your coffee, grab your cookie, and maybe keep the cookie away from the production line. Because today we are talking about animal feed dust. Yes, the dust that smells like grain, sticks to everything, attracts every insect in the county, and somehow turns your entire facility into a powder-covered barn. My name is Michael Klepik, and for 15 years I have been designing dust and fume control systems for feed mills, grain elevators, pellet plants, premix blending, and bulk handling operations. Let me break down what feed dust really is and how we control it safely. What animal feed dust really is. Technical description. Feed dust is a mixture of organic particles released during grinding, mixing, pelleting, drying, and packaging of feed products. Technically, it includes: first, particle sizes ranging from 1 micron to several millimeters, with the airborne portion typically from 1 to 100 microns. Second, bulk density from 200 to 600 kilograms per cubic meter, depending on the feed formulation. Third, airborne concentrations that can reach from 1,000 to 30,000 milligrams per cubic meter during grinding or screening. Fourth, a mix of starches, proteins, fibers, oils, minerals, and additives. Fifth, natural moisture absorption, making the dust sticky at higher humidity. Feed dust is organic, energetic, and unpredictable, not at all the same as mineral dust. Where feed dust appears in industry. Feed dust is generated at nearly every stage of feed manufacturing. First, grain receiving, cleaning, and conveying systems. Second, hammer mills, grinders, and roller mills. Third, mixers and blending tanks for vitamins and premixes. Fourth, pellet mills, coolers, and crumblers. Fifth, screening systems that remove fines. Sixth, bagging, filling, and packaging stations. Seventh, bulk loading for trucks, railcars, or storage bins. Any point where feed is dropped or transferred generates dust. Why feed dust is dangerous? Feed dust introduces several major hazards. First, it is a combustible dust with a low ignition energy. Second, organic dust explosions are common when clouds form in confined spaces. Third, dust inhalation can cause respiratory irritation and allergic reactions. Fourth, oils and proteins in the dust can create sticky buildup in ducts. Fifth, dust attracts insects, rodents, and contributes to contamination. Sixth, accumulated layers can ignite when exposed to heat. Feed dust is one of the most dangerous organic dusts because it burns rapidly and violently when suspended in air. Physical behavior of feed dust in airflow. From an engineering perspective, feed dust behaves in several challenging ways. First, it is lightweight and remains airborne for long periods. Second, it forms dense cloud bursts during dumping or grinding. Third, it absorbs moisture and becomes sticky inside ducts. Fourth, fats and oils in the feed mixture reduce filter life. Fifth, it generates static electricity during pneumatic transport. Because of its behavior, I designed duct velocities from 4,000 to 5,000 feet per minute. What filtration equipment works best? Feed dust characteristics require robust filtration systems. For fine organic dust, I often use a faux Chen cartridge collector. First, it captures fine airborne feed particles efficiently. Second, it provides high filtration area for continuous processes. Third, it supports strong pulse cleaning to handle sticky dust. For heavy dust loads, a BagHouse Blizzard is often the best choice. First, it tolerates heavy loading from grinders and screens. Second, it handles fibrous and sticky feed blends well. Third, it is durable and easy to maintain. Explosion protection. Because feed dust is fully combustible, I always include: first, explosion vent panels. Second, isolation valves for duct safety. Third, anti-static filter media. Fourth, complete grounding of the system. Fifth, optional spark detection for mills and grinders. Capture hood, designed for feed processing. Proper hood design dramatically reduces airborne feed dust. Effective methods include: first, enclosed hoods on hammer mills and roller mills. Second, capture points inside mixers and blending stations. Third, enclosed conveyor transfer points with side draft capture. Fourth, bag dumping stations with integrated downdraft design. Fifth, telescopic loading spouts with built-in dust removal. Good hood design protects both operators and equipment. The most common mistakes I see with feed dust. Across feed mills and grain facilities, I consistently observe: first, using duct velocities too low for lightweight organic dust. Second, installing collectors without explosion protection. Third, allowing dust to accumulate on rafters, beams, and floors. Fourth, using filter media not designed for sticky or oily particles. Fifth, not grounding equipment, leading to static buildup. Sixth, mixing fine feed dust with mineral dust in the same system. These mistakes increase explosion risk dramatically. What I always do on feed dust projects. My engineering approach includes: first, identifying the exact feed composition and oil content. Second, measuring dust load at each process point. Third, designing ductwork specifically for lightweight organic particles. Fourth, selecting filters that withstand sticky dust and proteins. Fifth, including explosion protection and isolation systems. Sixth, adding anti-static measures throughout the equipment. Seventh, ensuring easy cleaning and inspection access. These steps create a safe, reliable, and compliant system. Animal feed dust may smell like grain and look harmless, but it is lightweight, sticky, combustible, and capable of forming explosive clouds during normal operations. With proper airflow, correct filtration equipment, and robust explosion protection, it can be controlled safely and effectively. I am Michael Klepik. Protect your lungs, protect your equipment, and remember, feed dust belongs in the collector, not floating around your facility like it owns the place. See you in the next video. You in the